Hi, my name is Yudi, and I'm a PhD student at National Cheng Kung University, Taiwan, and also a member of the Intelligent Knowledge Management Laboratory. Today, I'm happy to present our work, rumor detection on Twitter using Multiloss, Hierarchical BiLSTM with an attenuation factor. This is a collaboration work with my colleague Chiawan and our advisor, Professor Kao. Currently, social media has a significant influence on people's daily lives. With social media, people can share information, speak freely, and reproduce news online conveniently. Take Twitter as an example. Over 500 million new tweets are sent every day. That is nearly 5,787 tweets per second. However, unverified information or rumors is also diffused in social media. These rumors can threaten people's health, endanger the economy, and affect the stability of a country. Take this tweet as an example. In 2013, the Associated Press official Twitter account was hacked and sent out a rumor that the President of the US was injured in an attack. This rumor caused wide panic and resulted in a brief crash of the stock market, in which investors lost $136 billion in just 2 minutes. Therefore, an automatic rumor detection system is vital on social media. This is an example of common tweet. It has source tweet, some comments, and some metadata, such as user attributes and tweet attributes. Most of the previous works on rumor detection rely on an individual tweet or tweet metadata to detect rumor. But we know that tweet text is short and make it hard to classify it. Our work is using source tweet and comments and combine as an event. To clarify, this is the structure of the dataset. The dataset has multiple topics. We define it as T. Each topic contains multiple events E, and events consist of a source post and comments P. Different topics have a different number of events, and events contain different numbers of posts, which means our model can handle variable length information. This is our model. We call it hierarchical structure with multi-loss and an attenuation factor. The model consists of two levels, post and event level. The input is all posts under an event. First, we encode the text to vector using GLAF. Next, all the vectors with the post as the unit pass through the post level BiLSTM layer in proper order. Then, the final state of the post level is joined and forming an event matrix where each column is a vector representing a post. Finally, the event matrix fed into event level BiLSTM to classify rumor. The multi-loss function helps achieve rapid convergence, but it reduces the accuracy. To realize the rapid training of the model while maintaining its precision, an attenuation factor is added in the backpropagation, which decreases to zero as the number of training epochs increases. We used the rumor datasets on the experiment, PIM 2017 and 2018. For the hyperparameters, the maximum value of vocabulary is 25,000, the batch size is 64, the dropout rate is 0.5, the hidden size unit is 256, and the learning rate is 0.0001. We compare our model with the following models. First, SVM BOW is a SVM classifier using bag of words and n-gram. Second, CNN is a convolutional neural network model. Third, BiLSTM is a bidirectional RNN-based tweet model. Fourth, BERT is a fine-tuned BERT to detect rumor. Fifth, RDM is a method that integrates GRU and reinforcement learning to detect rumors in the early stage, which is the state-of-the-art model. In the result table, we can see that the MHA model yields the best performance. The SVM-BOW result is poor because the traditional statistical machine learning method is not able to capture helpful features in this complicated rumor detection task. For the CNN, BiLSTM, and RDM models, the results are worse than those of our model due to the lack capacity of information extraction. Those models process information based on post and cannot obtain high-level representation from a hierarchical structure. BERT achieves state-of-the-art performance in many NLP tasks. It has multiple layers and multi-head attention and can mine in-depth information. But this structure is also based on posts and does not consider the post-event structure. To strengthen our research, we conduct an ablation study. First, we suggest that rumor detection based on an event is more credible than rumor detection based on a post. To prove this point, we conducted an experiment in which two models with identical structures and parameters were used to detect rumors in two different datasets. These two datasets contain the same text information. The only difference is that one is based on the post and the other is based on the events. From the experiment results, we can see that the accuracy of the model with the event dataset is approximately 7% higher. This result verifies our assumption that rumor detection with events as the detecting unit is more accurate. Next, we believe that the hierarchical structure, which has an advanced processing unit, is superior to the general structure in terms of extracting more complex and more in-depth information. To prove our hypothesis, we compare the general BiLSTM with the hierarchical BiLSTM. The hierarchical structure has two levels, namely the post and event, in which the output from the post level becomes the input of the event level. We use the same parameters for each module to ensure a fair comparison. The figure shows that the hierarchical structure outperforms the general structure in terms of accuracy, precision, recall, and F1, which confirms our hypothesis that the hierarchical structure has strongest detection capability. Then, we also evaluated several internal models to show how the multiloss function helps in rumor detection and to further investigate the impact of the attenuation factor in the proposed model. First, hierarchical H is a BiLSTM hierarchical structure model. Second, multiloss hierarchical MH is a multiloss BiLSTM hierarchical structure model. Third, MHA, a multiloss BiLSTM hierarchical structure model with an attenuation factor. We compare the training result of the H, MH, and MHA models on the same dataset with the same random seed. The figure shows that the MH and MHA which are multi-loss function models, learn faster than the original hierarchy model in the first 30 epochs. Moreover, the loss in that model decreases sharply. This result proves that the models benefit from post-level backpropagation by applying a multi-loss function. The attenuation factor in MHA gradually decreases to zero until epoch 15. This attenuation factor makes the MHA model learn based on only the event label, whereas the HA model continues to tune the parameters based on both post and the event information. With this technique, the training process becomes faster while maintaining the loss decreases. Finally, to evaluate the model's early rumor detection performance, we considered 6 types of test sets that reflect the real scenario of rumor spreading on Twitter. A small number of posts for each event means that the rumor had just begun to spread, with only a few tweets about the rumor. On the other hand, a large number of tweets implies that the rumor has spread widely. The test results shown in figure indicate that our MHA model detects rumor better and with higher accuracy in the test 5 dataset than the other methods. This result implies that our models can classify rumors very early. Furthermore, our model also performs well in other test datasets, which indicates that our models can be used to detect both new rumors and widely spread rumors. In this paper, we introduce a multi-loss hierarchical BiLSTM with an attenuation factor model for rumor detection. By means of the hierarchical structure, the model can learn deeply from limited text. The multi-loss function makes the model learn efficiently and robustly, while the attenuation factor at the post level helps to increase the accuracy of rumor detection. The experimental results based on 2 PIM datasets demonstrate that the model consistently outperforms other models by a significant margin. And on the application study shows that our model can be applied to both early and widely spread rumor detection with only a few modifications. Thank you.